Hi, good morning. It's Gene from the maverickstar Observatory. Guys, we've been working on a little project for the last 3 or so weeks in trying to get an organisation over here in the UK to give us a bit of funding for a project that we're proposing. It involves, if the funding comes in, 10 schools in Warwickshire where we live. It's like a county, and what we're going to do is select 10 of these schools, and we're going to put together a little package for each school, which just requires the kids getting involved in a science project, a citizen science project, and taking some CO2 samples. So what this means is that we're going to give these schools 10 CO2 detectors, and the kids are going to every week take a sample inside the building and then outside the building and write it down in a book that we're going to get printed. And obviously there'll be an SD card in the CO2 detector, which will record all the data on there for us as well. So at the end of 1 year, we'll have hopefully inspired young children to get involved in science projects, and also in particular let the children find out for themselves what the facts are behind CO2. And I think I thought when I come up with a plan, I've mentioned it just a few people, they said what an ingenious way of teaching people the true facts of CO2. You're giving them equipment, you're inspiring them to get involved and take an interest in science, and then second of all, not only that, you're actually collecting data in a county. Now, if it works well this year with the 10 schools that we send out these CO2 detectors to, and we generate some interest, then we'll probably expand it a little bit further across the UK, and who knows, the year after then we could take it globally. The idea behind this is that the children teach the adults, you see. And how can the adults then teach the children that CO2 is such a big issue if the children know that if they're in an environment where it's probably 1200 to 1500 parts per million, and if they go out to an environment outside where that drops to just over 400 parts per million, then how can it be a dangerous environment outside compared to what's inside? If CO2 is a real ugly particle or molecule, then how can it be so bad for people if that's the case? So that's our little black op that we've had going for the last 3 weeks. We're just hoping that we get the funding for that, and we'll have the books made up and we'll make the order for the CO2 detectors, and then we'll also get them out to them 10 schools and set it all up. I think you have to address these issues that we face in similar manners like this. You've got to take an active role in actually bringing out the truth, and hopefully if the kids are getting involved in these projects like this, and there's other projects we can do, and there's bound to be more questions raised than just how come CO2 is higher in a classroom than it is out in the open air. Does that mean our oxygen is also lower because there's more CO2 in the environment? And it's obviously, as we know, because that's why I built the oxygen sensor. We know that just because more goes into this reservoir, it doesn't push out oxygen as a result of that. We have a massive reservoir of oxygen in our atmosphere, and therefore as a result of that, it is going to be very difficult to deplete that reservoir of oxygen. So if CO2 does rise, it doesn't mean that oxygen is going to fall as a result of that. I just wanted to, while we were talking, just show you some of the things on Pulse Shift News that we cover. I mean, on top of what we're doing already, we are also expanding our observatory this year. Again, we did a great job last year of expanding it, and again we're going to do the same this year. We're just looking at the sea ice extent, and as you can see for the Arctic, we are above 2017, so there is more CO2, there is more sea ice in the Arctic than there was in at least 2017, right at this point in time, 2016. And you can see the chart yourselves there, and if you want to study it a little bit more, go over to the website. I'm just going to show you just a few things of what we've got here on the website for you if you are interested in any of these anomalies that we've got. I'll just quickly say what we have. We've got solar data. I'll show you quickly. So, you know, these cursors change when, you know, the geomagnetic field isn't quiet, and also when we're having more solar X-rays, you know, it changes from normal to storm and things like that. But more than that, you can see on the disk daily, which is updated every day, the difference, whether we've got sunspots or not. Also, we've got this, which shows inbound CMEs or coronal mass ejections, or any radiation that is coming off the sun towards our Earth. You can see that in the center one, the yellow dot represents Earth, and we've got aurora live over the Arctic and Antarctic. We've got you know, the space environment overview from 2012, which we talked about. I'm still offering somebody out there, if they can get me a recent environment overview in this format, a bottle of wine, because I really would be interested to see what's happening now towards the end of solar cycle 24. Another one that's updated regularly is sunspots and solar storms, this chart here, and also this one here. And as you can see, we're in 2020 and it is pretty much bottomed out now and at the end of solar cycle 24. And it shouldn't come to a surprise, because when you look at this chart, we can see that the sunspots have been dropping off for the last 33 years exponentially anyhow. And as a result of that, you guys know by now, we have a shrunken heliosphere which allows more cosmic radiation in. On top of that, we also have, as a result of that, a weakened, on top of that, we have the magnetic poles reversing on our planet, again letting more cosmic radiation in. Excuse me. Just want to, you know, whilst we're looking at this, and we can see at 1760 the Industrial Revolution had began, and you know, mainstream organisations believe that it is at that point that we started to affect our Earth's composition in the atmosphere, and as a result we have created global warming. But what I will say is that, you know, we came out of the Little Ice Age before 1760 and temperatures had risen, and that is just proof that, you know, CO2 is not driving climate. Another common misinterpretation is that, you know, CO2 drives temperature, and you know, you've seen on some of the other charts that we look at, that's not the case. You know, temperature is the horse and CO2 is very much the cart, and the horse pulls the cart and not the other way around. We have also cosmic ray data on our website from other stations, so we're checking the neutron from other stations as well, and that data is recorded every day and put up onto the website from a couple of other observatories. We've got the volcano map, which again is updated more than a few times a day. If we can just get it to come down so you can see the active volcanoes that are in eruption only. So it doesn't show the ones that was erupting last week or yesterday, it only shows the ones that are in a state of eruption. I prefer to see it like that, because you know, we're not looking at rumbling volcanoes, because if it was, we'd have a lot more on that screen, and I prefer just a few that are in actual eruption, and we can say that that is fact, as opposed to it could be, you know, about to go off, or you know, it's been rumbling for a long period of time. What else do we have? We have global weather maps, radar, satellite, and they're updated, as you can see, every day. We also have temperature and precipitation maps, and these are also updated every day. And on top of that, then we also have, you know, daily sea surface temperatures. So there's a lot of information on our website that is getting updated all the time, and it's all as a part of a big effort, guys, to keep you informed. The reason why I put all this on this one website was to make it a one-stop shop for the, you know, those people that have an interest in what's going on their planet. They could come here and they could see what was going on. We've got space weather environment page on the channel, as you can see, detecting the Valerian belt. We've also got the electron content forecasts, and of course what we have on the other solar page again, but only in bigger charts, like the solar proton flux, the geomagnetic activity, as well as a few other things on there. And again, it's updated daily, guys. Another one we have recently added is the Schumann resonance, and you can see the fluctuations in the Schumann resonance. Now, a lot of people think or believe that they're actually, you know, their train of thought is affected by the background radiation. And what the Schumann resonance is, if you don't know, is counting the lightning strikes all over the surface of the Earth, and on average it's about 7.8 hertz per second, or 7.8 lightning strikes per second, and that's what gives us that background resonance noise that, you know, all the life on this planet is, according to some people, attuned to it. I will say this, that on the Apollo missions they did put a background resonance in the capsule for the astronauts, so there must be something in there if they did that, I would have thought. What else we've got? We've got a good learning centre on here, and also there's a couple of other pages dedicated to climate change, climate and pole shift, how serious it is, you know, a magnetic reversal. You can have a look there, there's quite a lot of pages. All you've got to do is go to that section where it says more and scroll down the bar, and you'll find, you know, all these different things there. And on top of that, guys, primarily we have the Earth's magnetic field data, we've got the trimag data and the magnetosphere data, which we run from here in the UK at the Observatory, and then our global stations are all in the maverickstar global data if you want to have a look at what's going on with the magnetometers from different parts of the world. Now, we've recently had Arizona come online. It's in test. It was in test for nearly a week. Now it's gone into active mode, so in a month's time we'll be collecting data. We'll be adding that to our global data, this one here, so there will be a link. We're going to be removing Southern California off there and replacing it with the data that's collected from Arizona. So when we get all that sorted, we've also got to add one for shortly Bali, one for Brazil, one for South Africa, and we're also going to be putting one down in the south central coast of Australia. So, you know, very shortly, guys, there's going to be a lot of data that we collect from this observatory, all there for you guys to see. And for the majority of you, you know, you get to see this without even outlaying a coin, yeah. But you must remember this, yeah, there is some serious people now that make sure we get a tiny little bit of funding. It, well, it's not tiny, it is a lot really, but it still doesn't even pay a single salary at this observatory. But what I'm saying is if we can encourage a few more people to come on board and back us what we're doing here, you know, then we can expand it even more, and we can eventually, you know, give these bigger organisations a real good run for the money. You know, a lot of time and effort went into designing all this equipment that we build. We've got our own particle detectors, guys. We've got muon detectors. The reason why we're so happy about that is because we are detecting upper atmospheric collisions from cosmic rays hitting our atmospheric particles and in turn producing muons. So if the muons get on the increase, we know that there's more activity going on in our atmosphere as a result of the collisions with cosmic rays. And you know why we're looking at that in the first place? Because simply the grand solar minimum and the Earth going through a magnetic reversal will both let in more cosmic rays, and as a result we'll be able to collect the data. But bottom line is, we need to keep being funded in order to do what we're doing, and if we want to expand this year and get more data on this event, that is one of the most significant events in our time, then we've got to do more to support it, guys. It's as simple as that. And I know some of you think I'm always mentioning it. Well, the simple fact is I'm going to, simply because I cannot fund it all on my own. If I was a multi-millionaire, I wouldn't even ask. There wouldn't be a link there. I'd do it all myself, because that's just what sort of person I am. But I can't do it on my own, and I need help. So the link is there if you want to help and, you know, support what we do here at the observatory. And I hope that you do appreciate it. We do a lot more than just talk like a lot of other channels do on these subjects. We actually getting the equipment out there, getting the data back, processing it, putting it up on the web, and informing you guys of what's happening, because it could be just 3 years away. We could go for a magnetic reversal in just 3 years. We are getting close to the 40-degree mark, and I know a few of you from the video that I did yesterday are talking about the 40-degree mark and the experiment that I conducted. So I think in a couple of videos time we're going to get the the magnets out and the compass back out, and we'll just show you what happens when you twist the magnet in the vicinity of the compass, how the compass needle responds when it's at 40 degrees. So, and it's no different from the Earth. The Earth has strong field lines, it also has weak field lines, and it is predicted that when it gets to 40 degrees it will be on the cusp of those strong and weak field lines. Now when the poles are in the strong field lines, they're held in their place, they stay there for many thousands of years. But when they go into the weak field lines, we get the skitty movement of the pin on the compass needle, and we are detecting this, and we have been since last January detecting this movement where we get what I call magnetic jets, where the the distance is swung 400 miles easterly and then 400 miles westerly in a short space of time, and then continues a natural progression of slowly migrating towards where it has been going for nearly 100 years now, and that is towards Siberia, and it's still migrating, guys. So I'll wrap it up here, guys. Link down there if you want to help support us. I'll keep you informed in our little Black Op project going on with the schools, and I'll say what I usually do. You have an amazing day, and I'll catch up with you again at some point in this week. As always, bye for now.